Okay, so what I have here is the 80-meter receiver that I built using stuff that was hanging around, and I added a case to it. I didn't have enough of the thick metal to go around the whole thing, so I used what I had, and I made a little hole on the top so I could stick in a screwdriver and adjust the oscillator coil if I have to. And I made a preamp that has a gain of approximately 10. And I can show you how well that works. I have a signal generator here, which is set for 3.75 megahertz at a 1 millivolt RMS output, and then it goes through this attenuator, and I have 60 dB of attenuation kicked in, so that makes it 1 microvolt when it gets over to here. And now, see if I can get the meter to show. That's without the signal generator turned on. With the signal generator turned on, you can see it went up quite a bit. About 1.5 notches on it. And here's the diagram of it. There's a 0.01 capacitor going from that 10K resistor to ground, and I found that by making it with a cascade type circuit, I tend to have a lot less problems with oscillation, and it's more controllable. Now let's hook it up without the preamp, and we'll see what Okay, so that's without the preamp being connected. It can barely... I mean, it's receiving it at 1 microvolt, but it barely moves the meter. There's some noise on it just by being there, not bad. I'm going to connect the signal generator. You can see it goes back up again. And this black toroid here, before I built it, I tested it by feeding the signal generator into it and putting a 100 ohm resistor on the other side to make sure it was going to be able to pass the signal through it. I wasn't sure what the core that it's wound on was going to be able to pass. And I also came up with a couple of input filters. Here's one for the 40-meter band. And here's one for the 15-meter band. And here's the diagram here of the 40 meter one, and here's the 15 meter version. And hopefully you can see this. I simulated it using LT Spice, and you can see that it has a fairly flat response throughout the 40 meter band, then it drops off on either side. And when I actually built it, I found when feeding it through and putting it into an oscilloscope that that's pretty much agrees with what I'm seeing here. So I think that concludes what I'm going to do with this receiver. I'll probably build another one at some point. And the lessons that I've learned is I should use a stronger BFO, because what I have in here, it works good, but on really strong sideband signals it starts sounding a little bit muddy. And I should make the VFO for the tuning in a shielded cage. That way I won't have problems with, you know, the case or the knob. And use an air core coil for the VFO. I just use the IF transformer from an old transistor radio, and it works, but I think I'd have better luck if I made a air core coil. And I should make an adjustable gain control. That'll make it easier on some really strong signals. And I found that proper grounding of the coils and sections definitely helps, because I tried originally just using a coil on the input with just the input side of the coil not grounded. When I put the ground wire on it, the noise dropped by half. And I should use mechanical isolation for the tuning control, not directly go into the capacitor shaft. So if I had some kind of a thing where it's offset and maybe went through a pulley with a string or a belt or some kind of a coupling that had some springiness to it, so that it's not gonna just pass all the vibrations from when I tune it through onto the thing. Although actually it's not working badly the way it is, but I think that would be an improvement. And I should make a low pass audio filter. Right now I just have a capacitor stuck in there to cut back on noise, but an actual low pass filter would work better. So I think that concludes what I'm going to be able to do with this receiver. I've learned a lot from it. I made it out of stuff that I had hanging around, and I'm quite happy with the way it performs. I'm hoping to build a better one at some point in the future, probably using a 9 megacycles with crystals filter. Okay, so I'll say 73s from N1BUS.